continue today's lesson with compound interest. Okay, so where we left off yesterday in our student journal on page 187. Okay, that's where we're at. That's where you're at. Okay. So, if we recall from yesterday's lesson, we had two different equations we were using. We were using an exponential growth and an exponential decay equation. So, remember growth and decay. I want you to tell your neighbor what the equation or the formula is for growth and the same for decay, please. All right. So, growth. How do we know if it's growth? Raise your hand, please. Yes, Kellen? Good. We'd have y equals a times 1 plus r to the power of x. Whereas decay, we have everything the same except for it says 1 minus r to the power of x. Now, I know also yesterday, I think we referenced this as t. Okay, so x and t, the same thing there. Now, the other thing that you keep in mind, growth, this number that's inside here, which we call our b term, our b term is actually bigger than 1. Okay? Here, our b term is, good, less than 1, but greater than 0. It's in between 1 and 0. Okay? Just so we know. Now, with compound interest, your compound interest formula is this one. Okay, compound interest, we have y equals p times 1 plus r over n times to the power of nt. Now, tell your neighbor, is this a growth or a decay function there? Growth or decay equation? Okay, I'm going to say growth. I'm going to say decay. Why is it growth? Good, you're adding in there. Okay, so please note it's growth because you're adding. And then also note to yourself the difference between this equation for compound interest and then our growth equation. Okay, what's the difference? Yeah.
P instead of an A.
Okay, it's P instead of an A. So if you want to think of it as still A, you could. In fact, I guess on compound interest, I forgot, this is actually, they use the letter A there because that stands for amount. Okay, it's not the same A as that one. Okay, so just so you were clear, this is still the same as that. Those two things are the same. The ones are the same. The pluses are the same. This R and this R are the same. This T and this T are the same. What are the only differences that this has that this one doesn't? Good. The ends. The number of times we compound something. So to define our variables, this is amount, this is principal, this is rate, this is time, this is the number of compounding periods. Okay? That is actually in your student journal, already done for you. Okay? It's on page 186. Okay? Principal stands for initial amount. Just like when we were dealing with growth, our A term stood for the initial amount. All right? Rate stands for our interest rate, just like it did in growth. T stands for time in years, just like it did in growth. The only new piece is the number of times the interest is compounded per year. Everything we've done so far, it's been once a year. Once a year. They haven't even said anything about it because it's always once a year. But when we worked through our problems yesterday and we're dealing with this, up here it said write an exponential growth function that represents population t in 2005. It said each year it increased by 11%. Everything's been yearly. Well, on these bottom problems, notice they don't go yearly anymore. They say $3,000 deposit earns 6%. If I were to cover up this last part right here, that part that says compounded quarterly, if I just cover that up and say, okay, $3,000 deposit earns 6% annual interest. Well, if we're writing that out, that's just our value. So y equals, what's our initial amount? 3,000 plus times 1 plus, what's 6% as a decimal?
0.06.
All to the x power, or the t power, okay? All right, well, now when we actually add that compounded quarterly, the way that's written right now, that's once per year you get that interest. Well, they're not saying that. They're saying it's compounded. Compounded means we have to deal with those ends. It's quarterly. How many quarters are in a year? 4. It's quarterly. Okay, like 4 quarters in a school year. 4 quarters in a dollar. There's 4. So we'd have to divide our whole function by, or excuse me, our whole rate by 4, because they're not going to give us 6% per quarter. They're going to give us 6% per year. That means you get 4 or 6% divided by 4 per quarter. It'd be like me saying, I'm going to give you 12 cookies I'm going to give you 12 cookies this year. Okay? And then we're like, well, when do I get them? Well, I'm going to give you them monthly. Well, that means you're getting how many cookies each month? You get 1 cookie a month. Okay? All right. Well, we're gonna divide by 4, and since we're compounding quarterly, we'd have to say, well, every year, where t is here, every year we are compounding 4 times. So we have to multiply by that 4 there. Okay? So write a function that represents the balance after t years. Well, t years would just be t. We'd end up writing y equals 3,000 times, what's 0.06 divided by 4? Well, this is one of those times when I said, hey, those of you that are waiting for someone else because you don't want to get a calculator out, don't be that person. Yeah, Logan. 0.015. Good. 1 plus 0.015, thank you. And then we'd have t times 4, which I'm going to write as 4t. I'm going to combine those two things. So my function, or my equation here, we get 1.015 times 4t. How is that helpful? Well, if I know the number of years that money's there, I could actually figure out what my interest would be. Okay, but I don't, so I can't right now. All right, I want to do the same thing on number 10. Okay, I'm going to let you guys write your function now using that same format.
I forgot, do like 7.2% outside or the 5,000?
Wait, what's that?
The 7.2 go inside the parentheses of the 5,000. Okay.
Okay, so you'll notice I started out with my exponential growth formula. Hey, it's not done, right? I just wrote it as exponential growth. And now, how is this compounded? Is it supposed to be compounded? Yeah, how do we know? Yeah, dude, it says compounded. It's compounded monthly. Monthly means how many times a year? 12. That means n equals 12 here. So we have to divide this by 12. And we have to multiply this by 12. Notice that's all you're doing that's different. That's it. Okay? So now when I calculate this, it's 5,000. And 0.72 or 0.072 divided by 12 is?
0.0006.
Thank you. So we get y equals 5,000 times 1.006 to the 12t power. How many got it? Well done. Any questions? Guys, so the compound interest is just little addition, little add-ons to that growth function. Take your earbud out, please. Okay? We got that? It's just a little addition to it. So what you need to be able to do now is recognize when it's compound interest and when it's growth. So tell your neighbor how you know it's compounded and not just growth.
When there's a fraction thingy in it or the exponent t has numbers in front of it.
What's your key words?
Compounded or compound.
Okay, how do we know? Yes. Key words like what? Like what? Like compounded, yes. You have key words like it's compounded. If you see it's compounded, then you have to use the compound interest formula. What if it doesn't say it's compounded? Then you don't. You just do growth. And just so you know, the growth formula, this will be the last thing I say about this and we'll be done with it. But the growth formula, thank you. I was trying to figure out how I want to write it there. The growth formula is that, how many times is it compounded a year? Once. So n is 1. Why don't they put the ones then? Hey, Kellen? Yeah, you assume it's 1, and what happens when you divide by 1? Same number, you get r. And what happens when you multiply t by 1? You get t. So it would be a waste of your time to put the ones when we compound annually. Okay? That's why we don't put them. All right? Exponential growth is compounded annually. All right? They just don't show the 1 there. N is 1. All right. Very good. Any questions?